exciting to have Jim Slotta here, who is our longtime collaborator from Berkeley, and also to have him speaking at the Sesame seminar because he's been a longtime supporter of people in Sesame, and he's had students from Sesame, and he's mentored enormous numbers of Sesame graduates, so he's got a very good connection to our community. Jim is a physicist by training from Case Western Reserve. He worked with Mickey Chi at LRDC, and you'll see her impact on his thinking as he continues to speak. And then he came to Berkeley. Jim is really the father of WISE. He was here when we all worked together, but Jim was the technology guru that inspired the design, and it's really continued ever since then to help shape the framework and the way that WISE has evolved. Jim is an amazing community builder. He builds community everywhere he goes. If you meet him, you will be in his community forever. And when you show up at a meeting, he will remember you and remember that you need to meet so-and-so because they have similar interests to yours. And that wonderful quality that has really sustained our relationship for over 25 years. That's a long time. Yeah. Has continued, to shape his work as well, because Jim really believes in finding ways to make communities stronger and have communities learn from each other. And we built into WISE many ways to do that. Jim was very instrumental in thinking about how WISE would make students feel community connections by working with each other, and the teacher feel connections to their students by communicating the information from WISE to the teacher. And then throughout all of his career, he's continued to explore these issues in a variety of ways, basically, jumping from the confines of two students at a computer to, at one point, this wonderful wall ecology program where every wall had information about the environment, and there were activities for students and teachers to interact in the room. This is really fabulous, and Jim set them up in many, many different ways. And in addition, thinking about intermediate ways for communities to work together, both on their own computers, on shared computers, and with the teacher in the room. And I think that Jim's gift is to constantly imagine how the new technology might enable things that teachers and students need to be more effective learners. He's really interested in what we can create as an individual and share with the community in a repository, and how that information can be transformed by each individual user and become more effective for the community. And I think he's pioneered in thinking about this from a practical standpoint in the classroom, from a theoretical standpoint as to sort of what does that mean with regard to distributed knowledge and building a bigger understanding of complex issues, and from the standpoint of teachers and students, how you can kind of make teachers and students have meaningful interactions and not create boundaries between their work. And also just in the kind of different ways that we can experiment about this, ways that we can test different approaches to community interactions and understand their potential implications. So I think what is really fascinating about Jim's work is the values that he brings. Just as he wishes us all to be a community to help us be effective community members, he brings that same value to the design of technology. And you'll hear that as you listen to him. So I'd like to very much welcome my friend, my colleague, my hiking companion, my skiing companion. We have built this shared view of many things in multiple locations, and I think we'll very much enjoy hearing what he has to say. Jim Slotta.
Great. be here, and you know you've arrived when you have a personalized water bottle. Yeah, so I'm going to give you an overview of what I've been doing since I left Berkeley, basically. But I mean, what we've done before I left Berkeley has kept going, and I'm still involved in the WISE community. Some things are actually closing loops after all these years, and technologically, and the ideas have continued to kind of cut across communities. So yeah, I will probably say the word community 100 times, starting here. Just to thank, I mean, this is sort of what our group looks like on any given Friday up in Toronto. And you know, to me, that it's more than a metaphor. This is how the ideas happen. This is how the ideas grow in my work. And there's other ways of making ideas grow, but from my experience, the way we build and develop everything we do looks kind of like this. And people talking, brainstorming, design work, everybody vets their ideas and everybody gets improvement. And in fact, there's theoretical traditions in the learning sciences around this, some of which grew up here, actually half a mile away, in Tolman Hall with Ann Brown and Joe Campione and their group of foster communities of learners. So today what I'll do is I'll start by just refreshing that discussion of learning communities, and then move into this notion of a smart classroom. That's something we talk about that way. It's not a room that turns the lights out when you're gone. It's something that knows who's in the room, what they're doing, where they should be, where they are, who they're working with, and what we've done to support that idea going forward, and then hopefully illustrate all of that stuff with a few projects that we've done over the years. And then finally discussing themes, and I'll add new directions to that, hopefully. So some of the questions that I ask myself, and we ask in our group, how do you design curriculum where students work in the learning community? How do you do that? Go. Figure it out. Can this approach help students learn more than just content, engaging them in authentic practices of discourse and argumentation? Can the physical learning environment actively scaffold students and teachers? So what does the classroom have to say about this? What if it told you where to go? What if you went there and found something you needed? What if there's things hidden that you have to discover? What is the teacher supposed to do in all of this? And how can we represent these designs in something more than the English language, which is great. But is there another way? Like other sciences have like formula. Maybe we could. Design, design, design. Everything design. All your favorite designing. We do this. Methods, thinking, learning design, interaction design, co-design, design-based implementation research. Yeah. Anybody want to talk about this stuff? It's a, it's a moment, I think, where a lot of people are talking about design, both in how we do the work that we do, but also you talk to, practitioners, and it's a lot about design and the power of design thinking, and I'm writing an audit of a curriculum now about design thinking. So there's a movement around design. People have transformed now. IBM's transformed itself through design thinking. So it's a whole other talk, but it certainly infused itself into our work. But starting off here about learning communities. I mean, this fostering communities of learners was where I sort of first tasted the idea, and that was born here at Berkeley. And I was probably born in Illinois, but came quickly here, and they actually built a great lab community. If you haven't read that, FCL, there's not a whole lot of it to read, but it's certainly what affected me first. And then but of course I looked at it and thought about it, but I didn't really understand it until Web 2 came along. Web 2 came along in like 2002 or 3, and we started to see all these people putting stuff into Wikipedia, which started out empty. Think about that. And you got this sudden visceral understanding that I never got through reading Ann Brown or Martin Scardamelia. That really, this is user-contributed content, but more than that, this is advancement of ideas based on the emergence of themes, the emergence and the kind of awareness of the people around me. And that really triggered my work in thinking about collective progress and thinking about user contributed content and thinking about just even valuing and how to bring that valuation to the ideas that Dor contributes to my learning community and how Colette can get access to that and that can influence her experience, right? Students' inquiry depends on ideas from peers. And of course, if you read that learning community approach, there's a whole bunch of structure and principle around how to make those things come to life. And Anne Brown and her work is quite distinct from Marlene and Carl Bereiter and their work, in that one of them is sort of focused more on structure and scripting and jigsaw grouping and consequential tasks, and the other one's focused on idea and idea improvement. But I'm the only person in the world who can look at those two things and see them as being completely commensurate. That's a superpower, so don't try it. It's a concept, you get it, right? Kids all work together. They understand themselves that way. Does that happen now in the mainstream? No, not very often. On the other hand, you can look at any group of people, and you can right here call it learning community. So there's a whole bunch of sliding grade scales, but the concept we're after here is to how to structure that and also how to make everybody in the room, including the teacher, aware that that's what's happening. And there's some challenges. Depth versus breadth, right? How do I cover everything when I've got to try to make them all a happy community and build on each other's ideas? How do I, if this is going to be complicated, lecture is easy, right? Make the slides, ask questions, and it's very digestible and very, you can become an expert with 10,000 hours of doing it. But this is much more complicated. This is nuanced. And it's not even bound, it's unbound. I'm not allowed to know how it's going to go, which you can say that about lecture too, but these things are complicated. How am I going to put kids into groups and move that, and then they're supposed to find each other's ideas. The ideas are supposed to be a big resource in the room. How do I manage that? You know, what is that? What does that mean? An assessment. What am I assessing? And how do I give feedback and when? And then finally, just to mention this sort of epistemological understandings that people bring to every experience of learning. And this, you know, a classroom experience, if you come in thinking it's going to be one kind of thing, including it to the teacher who thinks that, it's obviously an important challenge. So one way that we have responded, and the field has responded to these kind of challenges, and I certainly think FCL was this way, is through scripting and orchestration. Okay, scripting orchestration is you can read the learning sciences literature right now. There's a sub-discipline there that's around scripting orchestration from Fisher and his group at Munich. Pierre Dillenberg in Switzerland are talking about this stuff. Essentially, it's a functional specification. It describes like a theatrical script. All of the roles, goals, materials, rules, interactions, conditions, fully written out. But like a theatrical script, it is nothing until it is performed. Right? Imagine being a playwright and writing a play. Has anyone here written a play? Can you imagine how exciting it is when you see it performed the first time? Like the heart rate goes up, right? Or orchestra music. People here identify more with that. And so orchestration is about making it real and making it come to life. And actually, you are that kid in that group with that specialization who's going to build that thing that she's going to need in her other specialization. And so there's a whole bunch of work that's been done on technology use for that. Learning analytics in the back end of doing stuff around that. Ambient representations in our case to help guide people and give them clues. So this is one way that we respond to this challenge. Back to the scripting part. So I just want to mention pedagogical models. So a model is an interesting thing. Other scientific disciplines use models. Why? Because models hold commitments, hold theoretical commitments. They reify them, and they're generative. So models produce testable objects of design that hold those commitments, those conjectures. If you read Sandoval's conjecture mapping model of design-based research, it's similar, but it's not exactly the same because he doesn't have a model. He just has theoretical coherent conjectures. So a model's a little bit more. A model has a theoretical story to tell. Okay, and there aren't that many actual models in the learning sciences. It's hard to find them. There's a few. Here's one. I don't know if it's a good one, but it is one, because I said so, it is. We used it a lot, we've tested a lot, we've built, teachers seem to think it worked. And I'll just run you through it. So we started here. Whatever we do, this has to work in high school physics, okay? Has to do an entire semester of high school physics, okay? And if it doesn't, it's a fail, go make a new model. Okay, well, the very first thing we're going to have is accessible learning outcomes, or the teacher won't actually run it. You're going to have a teacher run, I'm not going to run a whole semester of high school physics. My friend who's a teacher here is going to do it. It's not going to happen if it doesn't have accessible outcomes. So whatever is produced here, the scaffold and inquiry activity has to produce these to the teacher's satisfaction. That's awesome. You should celebrate this great feature of our model. These are the hard part here, so we'll come back to them. But they have to use the community knowledge base, and there's an epistemic commitment that everyone understands they're in a learning community, and that you're super happy that they're all also contributing, because if it was just you, you'd be lonely and unable to complete everything because of the sheer volume of the task. So thank God for them, they're all here, and they're thanking for you. So this is this community thing. The orange box here is that we're all building knowledge with scaffolds to do that. So you're going to get nice entry forms. You're going to get nice headers on your pages, right, like Wikipedia did. And we're going to scaffold that knowledge construction to go up in there. It's not shown here, but that knowledge is going to be constructed strictly according to the learning content expectations for the curriculum. So if it's physics, it's going to be structured against the primary physics learning principles, and even down into the sort of lower levels, right? Why? So that we can grab them, semantically indexed when we need them, and pull them into these red things here, so that they then produce accessible learning outcomes. Okay, so we build out some knowledge, we then design some inquiry activities that you're using that knowledge. There's learning that happens in both these places, there's assessment that happens in both these places, but they ultimately produce outcomes that are accessible. You can imagine the need for technology at every single step. Two other things, one of them really important is that the content expectations and learning goals, there's a big structural mapping of the content domain, including process competencies that you want. They are a critical input into the design of these inquiry activities. This is what I learned from WISE in part, was how to build inquiry activities that address the content expectations through pretty cool open-ended tasks that still coerce you to get to an end that we need you to get to. But this one is the hard one here, because we're not allowed to, these are all unbound. We're not allowed to know them before you start running them. Take a minute for that. These are unbound. So because we need the community voice and the emergence of these themes from the community inquiry to sort of feed in, or you feel like you're doing something that we just wrote that you're just going to do. Okay, so we actually have to make these inquiry activities such that they depend upon emergent themes and voice that you put in. That's a tricky business. I'm not going to tell you how to do it, Robin, and you all know. It's also not 100%, so you never get with any model 100%, but we try our best, and this is the model. So it's a knowledge community inquiry. There are a lot of papers about it you can read. It's got some elements. Like, you'd rather see the examples than have me talk more about all that stuff. Some of the elements of KCI that I would just point to are, first of all, this epistemological commitment, this shared understanding about how we know, this idea that we're collectively constructing a knowledge base, and that includes social information like votes and tags. Collaborative inquiry projects are a hallmark that actually have to use the knowledge base. That's the rules. So we have these accessible learning outcomes, and that these are multi-week, usually semester in length. It's hard to kind of fold this in as now we're going to switch into community mode. So KCI is framed in terms of principles. There's 4 of them right now. There may be another one coming, but here's just one. Each of these principles I frame out in terms of epistemic commitments, pedagogical affordances, and technological elements. And there's trade-offs that happen there. But here's the one: the students work collectively creating a knowledge base that serves as a resource for their inquiry within a specified learning domain. Like principle. Within that principle, we have these commitments that we make. They have to identify as a community. The knowledge base has to be understood as a valued product that we see. Pedagogical affordances there are, first of all, that you can index that knowledge according to the learning domain. That actually gives you back in a wealth of opportunity. And that there's some semantic and scripting variables that happen. Technological elements, wikis, database tools. Okay, so if you know about, so I talk about a design triangle of those three elements, and that there are tensions across them. So if you kind of know much about like activity systems, it's reminiscent of that. It actually even maps on pretty cool to that, but I'm hesitant to go all the way in. But I definitely see these as activity systems that, you're declaring a value and you have to have a commitment, like Chin would say. You're kind of instantiating that value in some activity sequences, and the technological rules and tools are supporting it. And so, of course, if you change any one of those things, the other two have to accommodate. Right? Here's three more. Each one of them has been mapped against these dimensions. I think we've talked enough about KCI that you sort of get it. You have to use the knowledge base. There's collaborative inquiry activities designed to target the learning goals. And then finally, one I think is really interesting and important is the teacher has a role in the script. Okay, in KCI, you need the teacher to be centrally important, meaning it fails without the teacher. Okay, the teacher is not a guide on the side. Guide on the side is insulting to teachers. They don't know what that means. Go be helpful. So teacher in KCI is at the center. It all sits like the center pole of the circumstance. Students, I kind of see them as just learning in a bubble chamber. That's how I see them. They pop in here and they go where you tell them and they do what you tell them, and at the end they come out and they know stuff. Right? But you could go deeper into this. In fact, this is one place we're going to try to go deeper in. To understand the learning community is a model that values the students' diversity. It actually says to you, every community comes in, everybody's got a vector. Force, magnitude, direction, their background, their interest, their experiences, what they have for breakfast, how they get along with others, their personality. And in traditional instruction, that's all vector subtracted. That's all down to the lowest common denominator, and then I'm going to teach you. I understand you've got a vector, but that's not part of my model to use that. I'm teaching you to the shared space, and I hope you all learn good. In the learning community model, you're actually trying to vector add. You want those vectors to find each other, to build on each other, to support groups that are affinities, to work on things that are complementary. So it's not trivializing the student. I see the student as critical. I haven't quite formalized the student in the model, and that is one place that we're doing some more work coming forward. Research methods, just to mention them, I framed this idea of a model-based design research, which is like design-based research, but it's design-based research where there's a model involved. And that's because the model creates the design. So you crank that design out is not arbitrary. It's according to the model. So it's like conjecture method, sort of, but it's a little more formalized around that. And it's all done as co-design, which means the teacher pushes it hard. You don't just convince the teacher that you're going to do this and hope they agree with you. The teacher is going to push you, and you're going to come out with something that's sort of better. If you don't say better, you're wrong. It's the rules of co-design. So we've done a bunch of these over the years, probably about 10 or 12. Semester usually linked in different grade levels, 5th, 6th, 11th, 12th, in biodiversity and evolution and physics and grade 5, 6 ecology. Typically ended up in a PhD study. I'll tell you about one, the first one ever, real quick, just so you get a sense. I think this is back when we were first imagining KCI as being more of a Web 2 thing. that like kids should build and use content, and we should all cooperate and complement each other. And it was the first time it was framed as KCI. It was in a topic of human disease systems, done by Vanessa Peters, who's out here in Digital Promise right now, back in I think '08. And her questions were really at the beginning. What does it even look like? We had never taught this way. We've done WISE. We've done this and that, project-based learning. Never done KCI before. So it's really exciting. What's a good topic? How do you build it? So these were kind of some things she was looking at. We got together with a group of teachers at a local high school, 3 of them for 5 sections of this course. Okay, 102 of them. Oh, 4 sections. All this time I thought it was 5. Well, it's 4 or 5. And there were 3 types of body systems: respiratory, circulatory, digestive. This is simplifying a little bit, but essentially this is how the teachers wanted to try to communicate, and this is what they wanted the students to focus on. And they wanted to focus on disease because disease implicates all of the elements and the interactive elements of a system, and those systems interact with each other. And they interact with society and Canada, which is all about Canada for them, because they live there. We decided to take this idea of a wiki, because there was no Google Docs, and we said, let's build a wiki of disease pages. Okay, so let's make respiratory, circulatory, digestive wiki pages. But we don't just want to add a new page on that. We need you to make the page with our headers on it, indexed to the learning goals that we need to cover. So we created this kind of scaffold, right, where they actually had to first put their names and visit a circulatory or respiratory and some overview, and then after that it popped them out with a blank wiki page with the headers on them. And they could write anything they wanted as long as they used our headers. And by the way, they're going to get graded on our headers, and they better say what you want them to say. But otherwise, anything you want. Okay? It's a little bit of a joke, but it's WISE is that way too, right? You can design any house for the desert you want, but it's got to have heat and temperature elements, and you got to ground it against the theory. So they did it, and they did it great. And what happened was so count off by 3, respiratory, circulatory, digestive, respiratory, circulatory, digestive. You're in the respiratory group, go make a page. So first period, section 1 made a couple of, asthma, emphysema, started it off. 45 minutes go by, they're done. Next section comes in later in the day. The teacher says, well, we're going to use the same. You're not going to 4 people do the same curriculum. We're going to 4 people do the same curriculum. So they pick up where the wiki pages where the other group was, and they start adding new respiratory diseases. And then, maybe touching up the ones that someone else did. But a third period comes in, and teacher, all the good ones are gone. I don't even know any new respiratory disease. Well, go work on the ones that are in there. Make them better. Finish the thing. Did anyone add connections to Canada as the bottom header? Like, you do that. Go put some pictures in there. By the time the 4th one came in, they had 40, 50 revisions to these pages. There were 23 good ones. They were on all the diseases, and they had only taken 45 minutes to do it. So already the teachers were like, what? How did this just happen? The inquiry phase, so that was the collaborative knowledge construction phase, again, back in '08. The inquiry phase was, okay, now you're a specialist in respiratory. We need you to do something fun and cool. We need you to make a challenge case for your peers about respiratory diseases. And by the way, creativity is rewarded. So each pair of kids made 2 of these. Okay, so here's Snow White and the 7 Smokers, and a woman shows up and she's bleeding out the ears and whatever she's got that are connected to the science of that respiratory disease, whatever it happened to be. Okay, and then we don't tell you what disease this is about. Okay, but guess what? It was really hard for them to make these, and they had to exercise their knowledge about the entire respiratory system in order to do it. And we gave them, again, page headers that they had to do. Then they had to solve 2 cases from the circulatory and digestive, using the wiki that their peers had created. So ta-da, we just covered everything, and it was cool. Teachers loved it. They all said that the kids learned better. On a final exam, they actually did learn better. It was weird. This is the only time in my life I've ever had it this easy where they gave the same exam to the kids that they had given the year before, didn't change the other things that they had done, and we could actually see a bounce from what we had done. I try to tell people just how rare these kind of opportunities are to find this kind of data, but it was there. And we all were thrilled because we were playwrights that had just watched a play that we had written be performed. And it turned into these really cool things. And that sort of got the ball rolling. So that's why I still include that example at the top. And it is fundamentally about getting the students to work as a community, to build a knowledge base, contriving inquiry activities that leverage that knowledge base, that produce comprehensive coverage and outcomes in the end that are accessible. And the model has kind of progressed and improved since then, but that was the one that got us rolling. Well, I've never seen anything run in 5 sections, whatever. Sections of class that leveraged each other, that actually produced a benefit over doing it alone. That was a really unique and interesting feature.
I actually teach physiology.
Okay.
And where do the students pick up sort of the fundamental principles of how the systems work?
10 years ago. I will say a couple things. A, this is an elite school, it's a science academy, and the teachers tend to have advanced degrees in the areas, and
So they're still delivering some information.
there's around the edges mini lectures,
Okay.
there's around the edges, we're going to take a break and watch this simulation. There was a lot of other stuff that wasn't just the elements that I presented, but if you looked deeper into the headers on that page, they were things like describe the functions of all these elements of the system, describe the connections to other bodily systems. So the pages were long, they were like 2,000-3,000 words. But that wasn't the only way they covered the content of that course. There were other contributed elements, and it was 10 weeks. So teachers are extremely cognizant of the need to be responsible to those expectations. Anyway, it worked well enough for us to keep going. And then we started thinking about the classroom. Right about then I was talking a lot to Frank Fisher, and he was interested in this, that maybe these rooms are more than just containers for us to sit in. Already in this room we have a lot of things that are going on, besides that we're in rows, besides that we have this and food there. And rooms do a lot for the learning context, and in fact, the history of classrooms has a lot of treatment of the room. Especially if you look at elementary classrooms, there's a ton of stuff that goes on with the room that's really semantic, that's really pedagogical. And we just started thinking, okay, if you push technology into that, especially with some of these calm and ubiquitous technologies that we might want to think about, ambient displays on the walls that could call you over, personal devices that could give you reminders or recommendations, things that sense when you're next to somebody that you're working with, that we should work with this as an idea that complements the learning community approach. So it's not pushed hard into the model at all, but it's certainly something that we're now thinking of the room as the user interface of our curriculum and technology. Also, not all learning happens through screens, right? Not all learning happens through discussing. There's a lot of kind of searching and querying and reminding. There's embodied forms of learning that we are beginning to understand, right? There's performed inquiry that we're beginning to understand. So we really want to push into how to potentially support some of those things. Learning analytics, I just want to say there's a role for this in our work. Besides big data and educational data mining, which I think is data visualization, what about real-time learning analytics? Listening to what one group is doing and seeing if that could be relevant to another group. Listening to the progress and seeing if the teacher needs to be called over. Like, these are things that little agents can do, readily if programmed, and do work for you and for the teacher. So guiding community progress, responding to students, enabling these complex movements of people. I would like to say kind of enabling emergence and things that are not, that you need to leave unbound. The room can sort of help with that. And we began to think of the room as an active player along with the teacher and the technology environments in the orchestration. It's sort of like a three-legged stool. Curriculum matters too. Little intelligent agents are one way that we do that, and have done it in previous studies. I'll show you a couple of examples of using these agents to do things. Architectures, I'm not going to say a lot about this. A lot of real-time technological communications, messaging architectures have happened in the last 10 years, starting with XMPP and QTT, and we've been all through now React and Angular, and essentially it's all able to, without worrying about going up through some internet and waiting for a launched trigger to update. It actually can real time, you're co-editing in Google Doc. Like that stuff is big. It's more than HTTP, right? It actually now connects all of us in real time through messaging typically, and user interface, active user interfaces. And we've been looking at all that through workstations, tablets, touches, walls, servers, agents, forever, and we're still looking at it. We're talking about new ways of doing that now. But I want to jump out of that because it's sort of a moving target and it's always going to keep moving into some examples. Okay, so any questions now about models, pedagogy, that stuff? Before I show you Evo Room. Okay, so Evo Room was a KCI unit. It's real important to mention that because I'm going to focus only on the last one of the final interactive 75 minutes, actually 150 minutes of time. It was a 12th grade biology. Sorry, this is not Evo Room. This is physics. Okay, that is a picture of Evo Room. But the first example I'm going to talk to you about is physics. Okay, 12th grade physics. 2 classes, same thing though. We're going to mainly focus on the role of the smart classroom here to support a learning community. But again, this was a 12-week semester length where these students worked together in a really cool design to build their own examples of the physics principles and to cross-index them. They would go home and make physics problems that they would then bring to class. And the teacher would assign them out to other students who'd have to solve them. They would upload them. They were all indexed, so they were building a knowledge base. And in the final smart classroom activity, they had this really cool, we designed this thing where this project was really aiming to investigate smart classrooms. That's what Mike Tissenbaum's thesis was about. He actually didn't know a whole lot of physics, so that was a problem. But we had a good information science background, and he was willing to let the physics teacher and myself hold that disciplinary anchor. And the way we came to the final activity was, it was on Hollywood physics. So we said, let's make 4 areas of the room. And what Mike really wanted to know was, could I use the semantic metadata that was up there in that knowledge base to make the experience of this room, to let those intelligent agents actually coordinate us in experiencing this learning activity in this room. And so the learning activity was basically, we created 4 workstations projected on the walls for 4 different Hollywood videos. So there was the Fast and the Furious where a car jumps over a ramp and another car follows it over the ramp and passes that first car in midair and lands before it. Is that possible?
We're going to go no.
Sure. What if the second car was moving 198 miles an hour and the first car was moving 65? Oh. Another one was something about Mary where the little dog drags Van Schiller across the hardwood floor. Another one was Iron Man where he shot himself up a kilometer in the air and fell down. And we essentially wanted the kids to, and they all had different physics principles involved, frictionless motion or projectile motion and terminal velocities, and they all mapped against the knowledge base. And so with the teacher, we created 4 videos that sort of spread that index around. And our goal was every student had to deeply interact with all 4 videos in 75 minutes and solve it. Oh, then there was the A-team where the tank was falling and everyone was gonna die, but then they turned the tank and shot the gun to kind of give it some X velocity so it would land in a lake or something like that. And so they were supposed to set up, make the assumptions, make the assignments, and solve these problems in the end, right? But everyone's got to work on all 4, and you're going to work with different students at all different stages. It's going to be a bloody mess. And the agents and the teacher's not going to do anything. except be a guide on the side. No. Teacher's going to be a mentor at the center, but not have to assign people to groups, think about material, or any of that stuff. They're going to have consequential interactions with the students when called over by the agents. Now go. Okay, that's cool. We used a lot of ambience to show and tell people where to go. I'm going to have to kind of zoom forward through these or we won't get done. We developed a lot of materials. We developed a thing like collaborative groupware, where it was like a giant multi-user laptop when you walked up to one of these screens. It wasn't just seeing what's on the screen. What you had in your hands became a collective user interface to work with that screen, okay? So the very first thing we did was we had to go in the room and walk around. They were assigned 3 of the 12 physics core principles, and they had to swipe them onto each video that they thought they'd be relevant for. So conservation of, momentum, okay? You do that, and it would, of course, we're just tracking what you do on your tablet, but then it would show up on the wall. And so if I walked around and I attached my 3 principles, I think it was 3 or 4, to as many of these videos as I thought, then at the end of 2 minutes or 3 minutes, or maybe it was 10, the room sent me to one of the videos, the one that I had assigned the most of my principles to. And that's how the room, the agent, made the initial decision of what wall you started with. Right, and it had to do some fuzzy math to get all 16 kids assigned equally to 4 walls, but we did that math. Okay. The agent performed math. And then when you got to your wall, you were asked to do something else. The room went up to this entire collection of 1,500 physics problems that we had over the year, found the ones that had the collection of principles that were tagged to it, and downloaded all those principles to the 4 of us, all these problems, the 4 of us, on our tablets, and said, go through these and find ones that you think are similar enough, because you know how physics is, where you solve a problem and it's kind of like this problem, and so to solve this one, you look for ones that are similar, like the guy that dropped the penny off the Empire State Building. Maybe that would have similar equations to handle the Iron Man one. So they were going through, but how do I get 4 kids to sort through 150 physics problems now? Okay, I use a bucket agent. So we had the bucket agent assign Door 1, assign Ali 1, Colette 1, I got 1. And all we have to do is say, could this physics problem possibly be useful for solving this problem? Yep or no? Yep, goes to the board. Nope. As soon as I'm done, another one gets assigned to me. Bucket agent is just distributing problems. So this is Mike's research. He was really looking for ways that agents could do things that were moving us through this script. After we had assigned problems, then we would look for equations. After we did equations, we would set up assumptions. Oh, by the way, now you got to move to another video screen and take over where the group before left off. And in this way, we sort of moved everyone through this dance, through all 4 boards, until the final group actually set up. So the third group actually assigned the mass of the tank shell and the velocity, terminal velocity of the tank, or like they came up with the final assumptions. The teacher was called over to check those assumptions. And then they progressed to setting it up, and then the final group actually solved it and the videotaped their solution. And that was Mike's design for how a room could move 16 people through solving 4 physics videos using the equations that they had contributed all semester long. And there's papers on this if you're interested in reading more. But it was a lot of development of tools for this, a lot of, the teacher had a tablet that would say, go to workstation 3 and talk to the kids about thing. I'm just going to show you a little picture of what it looked like. This is in the classroom before. Here they are swiping principles. This is all out of order, some of it, but they're working in this kind of collective inquiry board. There's the video of the Fast and Furious up there. Again, this is at the very end where they're solving problems, so it's not directly in the narrative sequence. Here's the room telling you where to go, and people going. It's important to see what this looks like, because it doesn't look like this. I'm seeing now. It looks very different than that. And so that's the main thing I'd like to take away from this video, is some visual images of how this looks in a room as a teacher. There is Sean Brooks. And again, these are grown-up kids. He's in 12th grade. These guys are all going to go off to university and study engineering physics. So it's not a school that it's not a school that you can say this would work anywhere, but it's the kind of school that you probably should do this in the first time you do it. Let me just say that. Oops, okay. We get the picture. And with that, here's a picture. So how do I represent that? I just told you it in English words for like 1,000 of them or 2,000 of them. Right? Now if I'm going to write about it to you, and I have to write about it, I'm going to write 1,000 words. How do I represent these designs? I'm sick of not having whys. We never, recycling project, we tell the whole thing. There's no symbolic way of representing these structures. That's a formalism like other sciences have. How far has chemistry advanced because of the formalisms it has as a discipline? Right? Physics, notational systems. We should have a notation system. Dance has a notation system. I've actually looked at it because it could actually work well for something like this. Okay, how do we do it? So there's one way we started with the actual storyboard where Mike drew this out and he added agents to it when they were needed, and we put another, several rows below it. This is actually a social row where we were adding our own discourse around it. Then he turned it into UML. We've had a steady effort in our group to try to represent. Here's a schematic representation that shows agents in what they're doing. And I just wanted to include that in this talk because you need, people like me who are building complex learning designs. We're going to need these formalisms going forward. And it's a great topic for somebody who should do that one. I keep trying to get my students to take it on seriously, but it's a hard. Who wants to invent a language, right, or a computational scheme? But we keep looking at other ones, and we keep developing our own, and we're going to keeping. So some of the kind of agents that were involved in that: student sorting, consensus agent, bucket agent, student progress agent. And this was Mike's PhD thesis, and it's definitely been published twice. It's coming out in IJCSCL this year, including the teacher notification stuff. So if you want to copy that paper, I can send you advanced print. Here's Evo Room. Evo Room was another one that was profound in terms of when you saw it happening, you're like, this is not like any learning I've ever been part of designing before. Again, 12th grade, bio, evolution of biodiversity, 12 weeks, KCI unit. I'm mainly going to talk about the culminating activity, which was woven in a little more tightly than the physics one. This is Michelle Louis. Her work was asking, how can I build a hollow desk? Right? How can a cave-like immersive learning experience guide all 16 of us to learn? It's fine to say it. I just said it. Right? How do I actually do it? Are there principles? What are the kind of interactions we need? How does it connect to the wider curriculum? Okay. She's a designer by training and an artist. And some of the things that you'll see here when I show you the wider room, is that you have these projections on both walls that turn them into a rainforest, the big one. There's some stuff on the front wall that's KCI-like in the sense that it's representing our knowledge base as we're building it. There's natural rainforest sounds so that we're trying to immerse you. In essence, what we built was a rainforest that could be advanced through time, 200 million years. So we started 200 million years ago, 150, 100, whatever it says there. Now, there's a whiteboard and some projection. There's a touch table in the middle. Very important to understand Evo Room. If you brought your kids into an aquarium, we've done this before with Wise. When you get the kids in the aquarium, you know what it's like. Oh, look at the big fish. That's a big fish. Oh, look at that one. There's no connection to the learning there. This is a classic problem with zoo visits, with aquarium visits. What if I take a novice kid into a rainforest? What if I took him to a real rainforest? Down in Sumatra. It would be like, where's a lot of trees? Nobody wanted that with our Evo Room. We work all the time. We don't want you to be like, what am I supposed to do? We wanted actual engagement when we walked in there. Oh, what if I took an expert to a rainforest? Expert rainforest researcher to a rainforest. He'd be like crying and like the Matrix, and I see the trophic layers and I got evolution right in front of my face and can't believe I ever see. We wanted that. Okay. So the idea here is don't bring your kids into the EVA room as novices. Bring them in as a serious stakeholder in what's going on in the EVA room. I just need to say that. So these green circles are when they go in the EVA room. And this one is the first one where they actually saw modern day Sumatra. Okay. So what we did is we engaged the kids. We told them we're going to hire a designer, and there's Michelle, she's a designer, and she's going to build this really cool, immersive environment, but we need your help to figure out all the species that are in it and how they evolve from each other and different kinds of primates and other animals and plants, and you need to specialize in 150 million years ago, go. And so the kids took this stake and they really saw themselves as providing, and they did actually provide the species and evolutionary relationships to Michelle. So in a weird way, she kind of joined that learning community right there because she didn't know what was alive 75 million years ago in Sumatra. It turns out to be hard to figure it out. We just told the kids it's easy, and then they went and did it. It's actually kind of hard. They had to go to libraries, they had to go ask questions, they had to go write letters to biologists, because nobody's kept a clear fossil record of everything that was existing at a particular location. You go look at the fossil record and it's more like what's on Earth. So they did it, because we told them they could. Yeah. And we used what they did, and that's how we built the EVA room at all those times. And when it came to your time period, you were a docent in the room. So you were supposed to represent 150 million years ago and help the other kids work with that knowledge. So that right away raised the stake for everybody the whole time they were in the room, and it worked. So we engaged them in a content design community. I just said all this. And so then Michelle took that and rendered it, animated it, and projected it onto walls. And we would build field guides so that they could understand what the proboscis monkey was and who was its descendant antecedent in the evolutionary history. We built a script, we built a pyramid, and then the teacher had this great opportunity to move the room through time, and it was neat. And this was another one of those writing a play and wondering what the heck is this going to be like when we actually have it performed. Thinking there's a video here somewhere. So again, just so you can see and hear a little bit of what it looks like. Whoopsie. People are not sitting in chairs. There's the teacher. The front of the board is showing this cladogram, which is an emergent representation of all of their evolutionary relationships. You've seen these at museums. You can kind of show where everybody came from. And on the right would be modern day, and on the left is a very thin few species. We did a lot of breakout groups, a lot of sit-downs. This table at that point was a reference table where they could touch and open up. Back then, tables were big and new. So just kind of kept talking through stuff, and that again was, you could call this visionary work. We're just trying to understand what this could look like for a learning community to be guided by the room, and to have the object of inquiry be the room, and to develop meaningful curricula that actually engage them in consequential interactions and discussions around the room. Whoops, are we over at 11:30? Okay. Trying to be entertaining. I'll go fast through the last one. So personal groups and devices, large animated walls. I think these are videos. A lot of small group solo actions. This front of the room emergent public record, which the teacher was able to go and touch and open up any particular relationship, including all the notes around it. The teacher had periodic discussions about radiation events, and if somebody made a wrong one, it would show up as like, this thing actually came from two things, and that's not allowed, right? And so it was able to be a kind of a real-time, pushback on their relationship observations. And again, there were something like 27 applications that were developed for tablets alone on this thing. And Michelle, as a designer, was able to map these against wireframe diagrams and UML diagrams, and it's sort of what it took to do this well. It took an engineer, and it took a team. It took that community I showed you in the first place. Okay, last example, embedded phenomena. Even cooler, I'm building in coolerness, each one. Okay, embedded phenomenon changed this room into this room. Okay, this may be too cool for you actually. So we tell the kids, and these are grade 5, 6, that there's insects in all the walls of the room, but you can't see them. They're everywhere, maybe the floor too. And we call that an embedded phenomenon. And Tom Moore from Illinois is a collaborator. I'm working with him even now to do a new proposal on pushing this further. His idea was like nature. You know, in nature, a lot of kids, you know, teachers want to take kids out to the playground and observe by food webs. Okay. But if you go out to the playground, you know what you're going to find. You know, some piece of gum with an ant on it, and a bird poop, and a bug that you can't catch, right? You're not going to see a food web. You're certainly not going to see life cycles, and you're going to need about 8 years to do it well. So Tom said, you know, I could work with a population biologist and actually develop a simulation that's rich enough that we actually let these things loose in the walls. And they thrive, and they create colonies, and they create evolutionary, and they create a sustained population levels, and they eat each other, and it's all good, and it's here forever. You don't have to look at it. You don't have to study it. It's just in the walls. That's all. Go about your business. But if you want to, you can do a curriculum about it. It's just the walls that bugs them. That's all. Okay? And he did the whole thing with real serious biology and developed models. Also, I can change the humidity in each wall or the temperature in each wall, and it does weirdly produce slightly, you know, sometimes dramatically different subsets of the master food web of this fictitious species. Okay. Nope. And there's mold, and there's scum, and there's hot water pipes, and there's cold water pipes, and oh, if I put a wall scope on a wall, it's a special scope, you can see an X-ray view into the wall. So you can see a little bug skitter onto it, skitter off, you can see eggs being laid, you can watch them hatch. Okay, now, go figure it out. So we tell grade 5, 6s. Okay, one of them would be super scared because there's a lot. There's 4 different walls that vary, there's like 15 species, and they have larvae, eggs, and pupa, and adult fur, and they all eat each other. I can't do all this. Okay, but 30 of us can, with the right tools and technologies. Oh, and a model would help, you know, to build an inquiry curriculum around this, which Tom didn't have, but I had. So the two of us came together. He had a wonderful interaction for this kind of collective inquiry. I had a model that needed such, or could benefit from such, and then together we developed the technologies to support that inquiry, particularly the teacher's role in guiding them to make meaning out of what they saw. Okay. This is the old version, what it looked like. And you know, I probably scrubbed through this, you know, and you can sort of see there's some eggs there that just appeared, and they hatched. Yeah, they're probably hatched and things run out. And the kids love it. They're like, this, look what I just saw. So how do I, you know, Tom was using Post-it notes when I first met him. Put that up on the wall, you saw it, and the teacher's got to read all these Post-it notes. So you see that the kind of technologies that we built and the kind of model that we have could facilitate learning from this kind of thing. We've subsequently gone to Unity 3D and built, you know, when these guys eat each other, you see bits fly. Right? And you got different camera angles they can flip through, and it turned out to be easier to render all this by far than it was this one, just because he could get some students that were really good with Unity, and they were like, oh, he built that, and it was bugs, no problem. Brenda rendered each creature, and then they let them loose, and kids have no trouble believing these are real. Like, who here in this room believes these are fake? Not a single hand goes up. They fall in love. So what we did was we developed a KCI curriculum, okay? Besides, we're gonna first start by all mapping the master food web, which is a hell of a game. And when I see something eat something, I had to build a tool for them where they would say, this eats this, go. And it would go into some magic invisible knowledge base. But on the front of the room, it would show up as something the teacher could query and talk to the kids about. And when we were all done doing that for about 3 days, we had a huge set because, you know, maybe I got it wrong. Or maybe 4 of us saw different things. We could talk through and we could commit to what the final food web was. Then we acknowledged that the walls had different things going on, and we asked them, what does differ? Well, this didn't have those pipes. This had bricks, not plaster. this thing's 3 degrees warmer. Oh, okay. We're learning some ecology here. Let's talk about biodiversity. Let's talk about habitat. And then we assigned them to a wall. So you guys are on this wall, right? This is going to be your wall. Take care of this wall. You can name it. This wall. And then we whacked your wall with like a disaster. So we sent in an invasive species, or we spiked the temperature, and you came in and you're like, the species are all gone, and there's only one little scrambled egg looking thing. And now you have to fix the wall. You go, well, you're never going to fix the wall because the temperature's gone up, like the world. So what are you going to do something? Let's talk about what it means to have healthy ecosystem. You know, and so teachers were running a lot of that, and there was some side instruction that was going on. But essentially, this was a developing curriculum that built around initially observation of very simple things and got more and more complicated, and it went for 10 weeks. Rebecca Quintana, the researcher here, how do you design, you know, all the knowledge I have in this room, how do I make it visible? I could choose 10,000 ways of making it visible. What's the right way? What's the best way? What's a good way? And, you know, what is the form of discourse that happens around those things? So, for example, here's that thing where you dragged, this was life cycle, this turned into this, right? We just gave the kids a tablet and said, if you see anything turning into anything, drag the thing that it turns into the thing that turned into it, and hit enter. And then on the front of the board, the teacher would have this smart board, and she could touch this thing, this green blobby thing, and it would show what everybody said, anybody that said anything that turned into that. Okay, so 2 people said that thing turned into it, 20 people said that thing turned into it, 8 people said it turned into itself. Okay, now the teacher can work with this, right? Do we all agree that we think this must be it? What happens if 12 people said this one and 8 people said this one? The teacher loved that. Because now we have to figure this out. We're a learning community, right? How are we going to figure this out? He can raise his hand. Maybe we can go look, maybe I can use my phone to videotape to prove that it actually turns into it. Like, okay, any more ideas, right? This is how these teachers were wonderful learning. They were from Marlene Scarmelia's school where she does knowledge building, and they loved the added structure of this, but they also really kept that kind of knowledge building discourse going. Anyway, that's how the learning community progressed. Rebecca evaluated these things in terms of capturing any time things happen, encoding, writing about that. That's been published in a recent couple papers. I think this is just closing with a video of sort of what it looks like. There was this knowledge discourse environment we built called Common Knowledge. Well, here's a video.
In the corner. I wonder if there are similarities between those habitats because the habitats are really close to each other. It would be interesting if there were similarities or differences. So let's go
This
back
is
to
just
two
her
and
using
see
that
what we
touch
get.
board. I think I missed a video. Let's see if I can go back. Oh, here. So this is, again, just what it looks like, okay? No kids in seats. A lot of animated, excited interactions around the walls. A lot of opportunity for the teacher to coordinate and interact with small groups. And then a lot of emergent representations on the front. That's the teacher right in the center, trying to guide their inquiries. We gave them a couple things they could do when it came to problem time. They could add new species into the walls, they could trap species, they could add food, they could dump some food in there. So just some images of what it looks like, and again, you write this stuff on paper and then you see it performed, and it's exciting. That's the teacher sitting down in the middle of the room. These teachers were great. They learned to ignore the kids in productive ways. I'm going to be talking to her right now, so you will go find the answer somewhere. That was Ben. He's a really wonderful teacher. That's in the corner there. And they loved it. So I'm just going to say, the teachers on all these things were really impressed, continue to partner with us. Watching legitimate, authentic engagement in investigating imaginary bugs in the walls. But learning a lot about biodiversity, about food webs, about habitat, about remediation, connecting to climate change. That's it for me. I'm going to just close with a couple of discussion slides that, first, that collective inquiry is a new form of inquiry. It's one that involves everybody and needs to have everybody. It's not just parallel play. Again, same as other kind of inquiry, person relevant topics. Knowledge integration continues to be important to me. It's something that I learned with Marcia here. To think about kids, distinguishing ideas and building coherence. Scripting orchestration has been at the center of all of our work. The role of a model and scaffolding of technology, that kind of goes without saying, but you saw some examples here. And then finally, I just came back from a 2-year sabbatical in Boston, where I thought I might be staying forever, and now I'm back in Toronto, trying to figure out what's next. So this is all from that before time. What do I want to do now? And I just say, kind of where I am now is thinking a lot about student identity and formation of identity, motivations, meaning and purpose. This actually helped. Boston actually gave me some of this. Jesuit school, and they were really into meaning and purpose, and I was affected by that. This idea of epistemic conditioning, that in fact, it's a little bit like what Mickey Chi would talk about as an ontological commitment, that you have ways of knowing and learning that you have used before, and if I try to give you a new one, you have not the experience of that. So it's very hard for you to suddenly just switch it on. It'd be like asking a classical musician to play jazz. You get that it exists, but you can't just start doing it. And so how do I help instantiate some new ontologies and engage you in them in almost like an icebreaker or a patterned way? And another one is teacher knowledge and practice. I've been building these with veteran teachers who were experienced and willing and had wonderful students, and I'm now thinking a bit more about what does that take to do that? And if I wanted to talk to a new teacher cohort in a school in like Durham district or Toronto district, how do I approach that? And this is something that Marcia and Olivia and I spent quite a lot of time on around whys. So that's why I was avoiding it until now, because it's tiring, difficult, and unsolved. But still, we're going to have new ways of teaching and learning in schools. Absolutely not going to be lecture and exams. Someone's got to figure out models are good, I recommend those, but someone's really going to have to do this work on figuring out how people are going to learn in the 21st century. I think design is going to be part of it. I'm going to possibly work on design curriculum, kids designing stuff. But in order to do that, you really need to think, outside of these kind of pilot school settings. So we're doing some of that. And then, of course, media. We're building an Internet of Things. That's what Tom and I are working on now, is bringing objects to mediate those kind of interactions and tangible embodied interactions, and location tracking, identity tracking, and how do I know exactly where you are in the room? That's actually going to be a really hard problem. And then a white slide. We're done.
I'm sure you have questions.
I chopped the whole study out into leave questions. It was on learning analytics and group process flow rate, group helping support group process. But that one is a dissertation study. If people are interested, I can send any of this. Right. Questions? Okay, wait. First back there. Then.
Just thinking about how you characterize the novice field trip to Aquaria, I'm wondering what the role of the early zoo field trip was in involving them.
Yeah, so we started to, everything about KCI is structural to a fault. Like I get in trouble, mapping, domain. Part of that is a sense that it will fall between the gaps if you don't. So in this one, we started right off with like your 12th grade. What are your expectations? We call them expectations of fairly standards. How are we going to weave those into Evo Room? And if we do a zoo trip, how can we make those more real by a field trip? So we actually built a web app for them to use at the zoo on their phones, or the phones were still kind of new. This was 2011. 12, but some high school kids had them. And then they were scaffolded to go do observations of trophic layer, predator-prey, evolutionary. There was some, I can't remember it all now, but there was like early seeding of these ideas around forests and forest ecologies. They had an rainforest exhibit at Toronto Zoo. And the concept was, let's actually get them out there in a real one and get them to pay attention to salient things. Yeah, and it was not run around the zoo and find, go watch the orangutans play. It was, you have to come back. And we actually worked with Chris Quintana from Michigan. He had an app called Zydeco that we actually used for that. And Zydeco's still up and running. And it was, again, I'm not the only one that builds apps that collect people and show emergent visualization. So it's an idea that's in the learning sciences. And Zydeco was one of these. Zydeco was all about supporting argumentation, supporting evidence, and collecting it. So we brought all that back. They used Zydeco and another app. And when they came back, they had to come to class, and we showed them everything that they had from their trip. And so, 10 years of building wise projects here deeply set me in the need to build scaffolds, but also the need to kind of collect and move you forward through structural steps. And I have never let that go. That's what those red boxes are in KCI. Okay, we have Colette and Libby.
One thing I continue to love about KCI is how it's not the privileging ways of knowing, but like the need to have different ways of knowing, feeding, it's consequential, right? Like you need what he learned, I need it in my project. And so you have this need for different ways of knowing. And so I'm really excited about your next steps and the metaphor you had about the vectors and additive vectors rather than the subtractive vectors. So when you're moving into student identity, I'm wondering what ideas you might have for making that really consequential in the KCI model and in your implementation. I know it's brand new, but like what ideas are you starting to have?
Well, we're moving into, so KCI is going to be, it's always going to be challenged because it's a semester length and you have to really design for, Evo Room was 2 years of design. Okay, it was a major commitment, and that was 2 whole summers. And then she did a pilot test and we finally ran. And so we're starting to make smaller ones that are more active learning design, but still collective. And I don't want to say that KCI is dying or anything, but I'm aware of that model as being what it is, which is a full replacement value model for curriculum design. So where we're kind of going right now is a climate action curriculum, positive climate action curriculum that connects to student identity and the building of career identity. So we want to actually show, that we don't want them to go home and do an energy survey. That's not more than a sliver of the answer. We want them to think about how they're going to plug in. So that, my feeling is there's an angst building in middle school, and these kids are not being given any positive hope, and they're not being given any structural response from their school to say anything. And when somebody is saying nothing, you're complicit in the messaging that we're doomed. And part of that is because the teachers think we're doomed. And part of it is because we are doomed, but whatever, right? We don't need to tell the kids that right now, not that way. And plus, we're not really doomed because it's all projected on today's technology, today's knowledge. We're going to science the shit out of this. And we're certainly not going to do it by telling the kids that we're doomed. So we're going to show them the kid who's cleaning up the plastics from the ocean, and we're going to get them thinking about design and how that failed, and then failed again, and failed again. We're going to talk about sequestration, we're going to talk about politics, and we're going to basically get teachers to build these and share and exchange them. So it's around career identity, we're actually building a community for teachers that's international. So we're going to have 10,000 teachers on a MOOC in the summer of 2020, and then 10,000 more from China. So we'll have 20,000 teachers that are building and sharing these basically WISE-like curriculum around student identity, career, and inquiry. That's one. So that's happening. But KCI, I mean, I believe KCI. I believe that I've seen it work 5, 6, 7, 8 times, and I'm not sure where that's going to go. I'm tired of giving this talk. I don't want to talk this one anymore. So we're gonna. That's what I told them. You gotta push this. Wow me, you know. Time for some new stuff. So, Libby.
Yeah, I was curious what you think about, like, you have all this really interesting evidence on these new kinds of teacher-student interactions that can happen when, as you described, these emergent voices are the ones that are really driving the curriculum. And this idea that the teacher is still the one at the center orchestrating it. And I was curious what kinds of sort of traces of all that learning you think could be picked up in terms of this learning analytics space to help the teacher guide all of these different individuals in not just the classroom where you were working, which was this sort of expert isolated case, but in more typical settings. And I guess sort of more specifically, I'm thinking, like, do you try and help the teacher get a sense of the diversity of ideas, or do you try and help them say, these are the kids who are stuck, go talk to them, or sort of where would you enter that space?
Okay, so, I mean, I think even just sticking with these privileged rooms is already a hard enough answer problem before we go off. But imagine a software genre, right? Which is basically what we're talking about. I mean, you could have Kahoot, where we all vote and we see the votes, and you get to talk about the pattern of votes. That's legitimate. That's happening everywhere, in higher ed especially. PI method, peer instruction methods. And it's garbage in, garbage out. So if you use good Kahoot items, you get good discussion. You could have Nearpod, which is even cooler. I mean, there's a wealth of these kind of tools. Padlet is one I've been seeing a lot of lately. Padlet's expanded its functionality now. And so they're all basically affordances for interactions. They all allow you to potentially put something in that could potentially be structured in a way that could potentially be useful for meaningful pedagogical discussion and reflection and palm to forehead and advancement of ideas. So there's a paper that came out last year in Learning and Instruction by Crescencia Fong on her PhD.
What was the name?
Fong and me. That she talked about the common knowledge environment. Common knowledge is basically a brainstorming tool that we built. And kids make ideas around, in this case, I think her work was on solar system, on astronomy. And they're firing away brainstorm at first, right? And it's all going up, but they're also adding, no, they're not. First, it's just going up there, and the teacher can move them around into piles, right? So those two teachers that you saw with Vocology, this was a prior project. And they're dragging them all in piles, and we got 30 kids on 15 tablets, and you end up with 100 of these things. And now we find out that there's a bunch on moons and planets. There's a bunch on galaxies and quasars and black holes. There's some on, seasons and weather, and like she's got 4 piles. Then we use an agent, and she clicked a button, and they all got, the bucket agent sent them all out to us with those 4 tags that she added. And also if you want to add more tags. And so then we all tagging all of them. So just because that one was with stars and moons doesn't mean it's not also about, gravity, whatever. So they're all tagging it, and then these things re-show up on the board, so clear the board.
So it's like resorting them into...
Resort them, and they're all showing up radially around things that you can touch and filter and just see those, okay? And then she formed groups, okay? And then she clicked another button, and the group that formed around gravity got all those gravity notes, and the board got washed. I hate buttered board. Wash the board off. Now you're all sitting there with just the gravity notes, and you're filtering through them, reading and reading. These are exactly alike. Now you have to write proposal notes. Proposal notes are a different kind of note, and they show up on the board around gravity as a tag. And now the teacher's like, oh, wow, that's really cool what you guys did with those 27 gravity notes. You've got 3 proposals of things you want to go forward with. So by using a little bit of filtering agents and buckets and semantic tagging, we've advanced the classroom from random just ideas up on the board to tagging and gestalting them around themes, to then working on those themes and advancing proposals. And then what Crescencia did was send that group off to their whole other working side of the room where they actually did inquiry around those. So that's a tool that was used to help the teacher tap in to get that community voice, right? And to push it back and to guide and to lead. And you know, the idea that we can build agents to do any kind of thing with those, it's still sitting in the back of our mind. You know, that particular tool doesn't exist anymore, but there's stuff we're even looking at Wise discussion tool now to think maybe the way that, you know, Haruki's got it, it's very close to what you could do stuff like that with it. So I don't know, I mean,
Yeah.
I actually think there is a real patterned discourse there, like you mentioned, and that a lot of teachers are just been doing it, that it's not, that's ontologically proximal to things that we do with Kahoot and other PI methods, so it's not so alien to teachers that they'll be like, knowledge building,
Yeah.
but they can do this. And so, you know, it would be fun, where we are right now with Walkology. So Tom and I talk about Walkology. Like, Walkology should be shareable with the world. There's bugs in the wall on computer screens, right? Any teacher sees that would want that, a biology teacher. I have the bugs in the wall, and I also really want the tools that help the kids make the food web, and I also really want some, you know, very low hanging way to help the class feel like they're engaged as a community. This doesn't have to be deep and knowledge building, it just can be scripty and orchestrating. So we're going to start thinking about building tool sets that are like that, that are kind of tailored to that interaction. I really don't know.
Well, thank you very much.
We have
This
a
is
lot of
really
ideas.
exciting. We're
I need my
at the end of
community
our-
around me to answer.
bonus minutes, which is we never do. So welcome to everybody. Thank you, Jim, so much for this inspiring talk. I'm sure we'll be talking about it for weeks to come. And I'm sure Jim can hang around if people have specific questions. So thank you very much.